Hello, good afternoon, and welcome to another insightful webinar hosted by Secure Intelligence Limited. My name is Iyenu Ukonga Omowa, and I am a sales development representative at Secure Intelligence Limited, and I'm going to be your moderator for today. Today, on our series of the Well-Architected review, we're going to be talking about reliability and resilience building fault-tolerant systems with AWS Well-Architected. Please note that as we move forward, we have a few housekeeping rules that you need to adhere to in order for us to have a smooth webinar. This session is being recorded and uploaded on all our social media channels. So if for any reason you have to get up during the webinar, that's fine. You can go to our YouTube channel and there will be a recorded version of this webinar and you can see it for as long as you want or how many times you want. Attendees can react or raise their hands during the presentation. Other engagement required from attendees is at the discretion of the presenter. Also note that if you would need to book a consultation meeting, maybe you want to know more about our services, you can click on a link that will be put in the question and answer section of this webinar, and it will lead you to a calendar where you can book a consultation meeting with a sales development representative. If you have a question, please use the question and answer comment section during the session and have them answered at the end of the webinar. We are Secure Intelligence Limited. We are still teams and we are solution builders. We apply technology to drive effectiveness, agility, and growth for businesses. And our business is positioned to help enterprises scale globally. And we are positioned on these four pillars: the global mindset pillar, the multi-cloud competence pillar, the agility pillar, and the growth pillar. So without further ado, I would like to introduce you to our speaker for today. His name is Moshood Adams, and he's a cloud engineer with us here at Secure Intelligence Limited. Hi, Moshood.
Hello, Queen. Thank you so much for that warm introduction. Yeah, so my name is Moshood Adams. I am a cloud engineer at Secure Intelligence Limited. So I'll be taking us through the agenda for today. So we'll be looking at a brief overview of well-architected framework and the pillars under well-architected. We'll be looking at reliability as a well-architected pillar and its design principles. We'll be looking at techniques to design and implement fault-tolerant systems, strategies to strategies for effective disaster recovery in the cloud. We'll also be looking at methods to identify and mitigate potential systems failure, best practices for ensuring business continuity on AWS. Also, we'll be looking at insight into balancing cost and reliability in cloud architecture, and practical knowledge for improving system resilience. And finally, we'll be looking at improving overall system resilience. So kindly let me change it to the next slide. So when you look at I want to direct this to our audience. So when you look at your workload, your architecture that your team is building or you have in the cloud, so how well can you answer this question? Can you say you are well architected? So that's a question for you, my audience. So please kindly let me change it to the next slide, please. So I'll be defining what AWS Well-Architected Framework is. So it is a collection of best practices to be used when you are designing, when you are deploying, when you are operating your application on the cloud. So the aim is for you to have a secure, high-performing, cost-optimized, reliable architecture on your AWS. So it is an iterative mechanism in the sense that it is an ever-ending framework, in the sense that once you start implementing it, you must continue to implement it, because obviously you'll be having changes in your architecture. Maybe you have a new business office that you want to add to your application. So that would change the architecture that you are having on AWS. That means you have to maybe write more codes to what you have there already. Maybe you have like a new data that you want to like store on your AWS. That means you must use AWS well-architected frameworks. So for you to have a high-performing, cost-optimized, and reliable infrastructure, so you must continue to use these frameworks to be able to achieve all this that I listed. So we have verticals in AWS well-architected frameworks. We have the learn. So you have to like learn the best practices and strategies for your cloud journey. So when you learn these practices and strategies, you have to like measure against the best measure your architecture, what you have in the cloud. You have to like measure it against these best practices. And finally, you have to like improve this your architecture by addressing the issues that you found. Okay, this system is like this is what I have in my architecture, and it is not meant to be like this. This is the best practice. So you have to like improve, you have to like adhere to the best practice. So like I said, it is an iterative process, and whose goal is for you to achieve your business outcome for your architecture. Yeah, can you change this to the next slide, please? So we have pillars under AWS Well-Architected Framework. We have 6 pillars. We have operational excellence, we have security, we have reliability, we have performance efficiency, we have cost optimization, we have sustainability. So for the operational excellence, you have to run, manage, and monitor your workloads for you to be able to like effectively achieve this pillar. You have to like run, you have to manage, you have to like monitor your production workloads for you to deliver your business value. And like I said, it is AWS Well-Architected itself is a continuous process. So it is for you to like continuously improve on what you have, your process, your events, your resources that you are running on the cloud. So this pillar, what it does is to like help you run, manage, monitor your production workload to deliver your business values. Also is security. So this pillar is meant for you to protect your resources, your data that you have on the cloud from the outside world by carrying out risk assessment. You secure against unplanned failures. You have mitigation strategies. So by adhering to this pillar, you'll be able to like securely save, protect your whole architecture. Also is reliability, which is automatically recovering your workload from infrastructure, power, or systems failure for you to meet your operational threshold. So when you have this, you'll be able to like recover your workloads, your systems from failure. Also is performance efficiency. So this is using computing resources efficiently to support your on-demand workloads for you to meet your service level agreement, for you to meet your internal service level objectives. Also is cost optimization. This is for you to avoid and eliminate unwanted costs and replace them with cost-effective resources without you impacting best practices and your business needs, without you impacting your architecture. Like this pillar is to protect you from like having being wasteful on the cloud. Like it will tell you, oh, this resources is the one meant for you. This is cost efficient. You don't have to like go over the board. Adhering to this pillar, you'll be able to like have a cost optimized workload. And lastly is sustainability. This pillar aims to like minimize the environmental impacts on your workload. The environmental impact, especially in the areas of energy consumption and efficiency of your running workload. So by adhering to this pillar, you'll be able to minimize the environmental impact that your workload is having. So those are the 6 pillars under AWS Well-Architected. So in today's world, this digital age, obviously organizations rely heavily on technology to function. However, outrages and disruptions, they can have big business operations, they can impact business operations, your customer satisfaction, and even your revenue. So that is why reliability and resiliency, they are important. So we'll be looking at reliability. So this refers to your workload ability to perform its intended functions consistently and correctly over a period of time. So it is about minimizing downtime and ensuring consistent service delivery. So let's assume that you go to a dealership, car dealership store, and you went there to buy a new Ferrari, and they told you that, oh, this Ferrari accelerates 100 kilometers in 60 seconds. So maybe they will tell you that, oh, for the next 10 years, it must like you must be able to achieve 60 seconds in 60 seconds 100 kilometer. So this your Ferrari must perform its intended function consistently. It must not, okay, maybe you today that while driving you're able to achieve the 60 hours 100 kilometer, and tomorrow you are not able to achieve. That means your Ferrari is not reliable. That is actually very bad. So it is very important for your workload to be reliable, and also is resilience. So this is building on reliability. So it is about your workload's ability to recover quickly from failure or disruption. So it is about you anticipating issues and having mechanism in place to bounce back with minimal impact. So resilience builds on reliability. And I said reliability is your workload's ability to perform its intended functions consistently and correctly over the defined period. When you have your workload, it must perform the function it was designed for consistently and correctly for a defined over a defined period. So that is that. Please kindly let me change it to the next slide. So under reliability, under reliability, which is a pillar under well-architected framework, and like I said, it is the ability of your workload to perform the functions correctly and consistently when it's expected to. So we have design principles under all pillars in well-architected frameworks. So the purpose of these design principles are that the purpose of these design principles is that they are like a guide on how to achieve the pillars. So they are like a roadmap, a guide on how to achieve the pillars. So for all the 6 pillars that we have under well-architected framework, we have design principles. For the design principles under reliability, we have automatically recovering from failure. So by having metrics, your workload metrics, you can say, oh, maybe the metrics for your server is CPU utilization, maybe the network in or network out. You can have system in place that would like make it possible for you to anticipate and remediate failure. So when you have like an instance where you have maybe your server is getting to maybe 70% or 80% CPU utilization, obviously you should know that it is a problem. If it gets more than that, or maybe from that 70 or more than that, it will crash your server. So you have like an automation in place for you to anticipate and remediate failures. So we'll be talking about that at length. We also have test recovery procedures. So this approach exposes your failure, the failure pathway that one can test and fix before a real life failure scenario occurs. So an example is Netflix that uses Simian Army. So what Netflix uses AWS Cloud. So that's their public cloud provider. So that's what they use, and they have like a system that they call Simian Army. So what this Simian Army does is that, assuming they have like 100 servers, this Simian Army like randomly terminates 30 servers, like that's an instance, right? 30 servers in their server, like 30 servers. So what they are trying to know is that, oh, if this Simian Army terminates 30 servers, the remaining 70 servers, can they actually like work perfectly for our demand? So this is what, like, having that in place, they'll be able to like fully understand failure scenarios and know how to go about, oh, when this system terminates these instances, okay, these are these are the roadmap on what to do. These are they can text and fix real failure issue before they occur. So this is going to like reduce risk. Kindly change it to the next slide, please. So please, if you have more questions, if you have any question, please do not hesitate to put your question into the in-call messages. So once I'm done with this, my presentation, I'll take them. So yeah, so thank you. So another design principles under reliability pillar is scaling horizontally to increase aggregate workloads and availability. So we have a concept in AWS where we call scalability. Also, this scalability is divided into vertical scalability and horizontal scalability. For vertical scalability, let's assume an instance where you have a non-distributed system like a database. So for the instance servicing your database, let's assume that you have 4 gig of RAM, you have a quad core of processor there. So maybe there is an increase in demand and you need more. So this vertical scalability means you are increasing the size of the servers that you have into something bigger. So you only use this in non-distributed system like database. So while the horizontal scalability means you increasing the number of instances that you have. Let's assume that, oh, you have an instance and you need more instance. You don't for this scalability, what you be doing is having more instance to assist the instance that you have. You have a single instance and you have more demand. You can have two more instances that would support that previous one that you were having. So also is stop getting capacity. We have a concept in AWS. We have a resource, an AWS resource that we call auto-scaling group, AWS auto-scaling group. This is a managed resource. What it does is that, let's assume that, okay, on Monday, the demand that you have on your server, like maybe it's like the server that you have, you don't get more than maybe 60% on that CPU utilization of that server doesn't get more than 60%. But on Friday, it's actually like that server cannot cannot meet the demand. So when you have when you set up when you use AWS auto scaling group, you can have more servers on that Friday without you needing to have that big those servers that you added by on that Monday you'll be able to you'll be able to go back to what you were using before, like automatically without you stressing yourself. You schedule your auto scaling group to every Friday increase my demand so that increase my servers so that when it gets back to on Monday, you don't have to pay for the extra servers that you have there that you set up. It will go back to the normal based on the demand that you have on Mondays. And lastly, managing change through automation. There's a concept in AWS that we call using infrastructure as code. In very little time, you can set up your infrastructure in different regions. You can set up your infrastructure in different regions just by using your infrastructure as code. This is like a template that has all the codes that would spin up your infrastructure. So that way you can easily have your whole architecture, your whole workload running, or your whole business. I can even call it your whole business running in another region by just deploying that template. But by that way, you can easily track and review your whole architecture. You can say, oh, I understand what is going on here. Yeah, I know what is going on, by being able to look at the template that provision that deployed your infrastructure. So all these design principles, these are still in Cecure Intelligence Limited. We set them up for you. We look at your requirements. We know we understand what you have and what you are trying to achieve. We understand your business needs, and we set all these design pillars for you. We do that at Cecure Intelligence Limited. So kindly let me take it to the next slide. So we'll be looking at building fault-tolerant systems with AWS Well-Architected. So a core concept of reliability pillar is designing one system with the expectation of failure. So this does not mean you are assuming anything will break, but you are not acknowledging that components can or will fail. There's no 100% fault tolerant system. It is actually not possible. So for you to design fault tolerant system, there's a concept that we call redundancy. This is you deploying your critical resources across multiple instances or availability zones, so that if one instance fails, others can pick up the slack. There's a concept that we call high availability. It is you having your servers in at least 2 availability zones, so that when a data center, when you lose a data center, the other instances can pick up the slack. Also, for you to achieve fault tolerant system, you scale. So you design your system to automatically scale. That was where I was talking about the auto scaling group, which is an AWS service. So for you to handle fluctuation in demands. So this prevents you from overloading and potential outrage during peak periods. So when you have your servers, you automate it and tell your auto scaling group that, oh, when it gets here, add more resources to what I have already in place. So by that way, you prevent overloading and potential outrage during your peak period. So we also have automated recovery. So you implement automated processes to discover and recover from failures. So this involves you automatic failovers to healthy resources or triggering self-healing mechanism. We have a resource in AWS we call elastic load balancer. So it sends traffic, it directs traffic to healthy instances. So that's what it does. So this involves it, like this makes you achieve automatic failovers to healthy resources, and also it heals your servers. And also we talked about you regularly testing your discovery recovery plan thing, because when you do this, you'll be able to know, oh, this is the process, this is what we have to do when this a situation like this occur. You know what to do, you know where to go to, you know how to fix issues when you regularly test your disaster recovery plan. Yeah, kindly let me change it to the next screen, please. Hello, can you hear me? Yeah, please let me change it to it. Okay, thank you. So we'll be looking at designing for effective disaster recovery. So these are core disaster recovery strategy, you backing up and replicating your data. So you implementing a robust backup and replication strategy for your data. That's a core disaster recovery strategy. So you like regularly back up your data to a secondary location or a different AWS region, so that maybe when your region, maybe you lose a region, you'll be able to like recover your data from the region that you backed up your data in. So we also have replication techniques to keep copies of your data consistently synchronized across across locations. So we have a service in AWS we call AWS S3. This is an object storage service that helps you store your service. No matter how big your file is, you'll be able to store it. So you using cross-zone replication in AWS S3, you'll be able to have copies of your data that are like constantly synchronized across locations. We also have NoSQL database that we call DynamoDB. So with DynamoDB, you can have continuous backups, which they are actually very valuable for your this disaster recovery strategy. Also is high availability configuration. I talked about high availability the other time. So I said high availability is you having your critical instances in more than a single availability zone, so that when you lose a data center, you'll be able to have the other data center that will fill in the gap. So it involves you deploying redundant instance of your application across multiple zones. So when you lose an instance, an availability zone, the other will will fill up the gap. So if a single instance or AZ experiences an issue, your service remains available through the remaining healthy resources. So we also, I also talked about auto-scaling group. So it can help you automatically provision additional instances based on demand. So, next slide, please. So also is failover mechanism. You implementing failover mechanism can automatically direct traffic from your failing resources to healthy backups. So this will help you to achieve minimal downtime for your application during disruption. And this AWS service that can help you achieve this is AWS Route 53 failover policy. So when you use routing failover policies, you can use it to migrate your DNS from one region to another. If you have like, you can say, okay, this failover policy, what it does is that if a region fails, it should like that migrate your DNS domain name system to another region. So we'll be looking at disaster recovery services. So we'll be looking at S3, which I said is highly is an object storage AWS services, a service resource that can help you help you to recover your workload during a disaster. So it's S3 is highly durable. Like AWS said, the durability of S3 is 99.999. That's 11 nines. So it is very durable. If you have 10 million files in your in S3, be rest assured that over 10,000 years, you can only lose a single file. It is highly very durable and it is also very available. We also have Amazon DynamoDB. Is a NoSQL database with continuous backup. So you using this resource, you can is a very important AWS disaster recovery service. Also is Amazon RDS. This is like a managed relation database that has multi-AZ deployment. So you can like deploy to multi-AZs. Also is AWS Backup. So this is a centralized backup management system across various AWS services. Using this resource, you can actually back up so many AWS resources. It is a central management platform for you to like back up your AWS services. And also is AWS CloudTrail. So this is for logging API calls for you to have for you to be able to audit and have post incident analysis. You'll be able to see the API calls. You'll be able to understand what is actually happening in your workload. So maybe this system is calling this system. Maybe it was not able to call it. Maybe there's like a disruption. Maybe something is disrupting this system from being able to reach this system. You'll be able to like understand by you checking your CloudTrail. It's a service on AWS that helps you to audit and have a post-incident analysis of your workload. Next slide, please. So we'll be looking at mitigating system failure. So even with the best planning, unforeseen issues can arise. So there are so many there are ways or strategies on how to identify and mitigate potential system failures on AWS. We have proactive monitoring, utilizing tools like AWS CloudWatch. AWS CloudWatch is an AWS service that helps you to continuously monitor the health and performance of your system resources. AWS CloudWatch provides detailed metrics on CPU utilization, network, disk space, application health. So these are the default metrics that you can get the information using AWS CloudWatch. You can even go further by implementing what we call unified CloudWatch agents. So when you install this on your servers, you'll be able to like see the CPU the RAM that your system, your server is using, you'll be able to see the application log. So when you engage us at Secure Intelligence Limited, we can help you implement this into your servers, because the default metric that CloudWatch measures on servers are just the CPU utilization, the network, the displays, and application health. RAM, random access memory, applications logs are not captured. CloudWatch does not capture those ones. So if you engage us, we'll help you set up unified CloudWatch agents on your servers, and by that way, you'll be able to like measure the random access memory of your servers. So by setting up custom alarm based on your metric, you can receive notification when thresholds are breached. So I said, oh, you can set up alarms that says, oh, when the CPU utilization on my servers gets to this level, notify me. So by doing this, you'll be able to like have a full pictures of how your resources are faring. So next slide, please. We also have automated remediation. So I talked a little about auto scaling group. This is an AWS service that helps you to handle increased load and prevents overloading. So when you prevent overloading, your server will not crash. So you can also have restart responsive services. You can achieve this using services like AWS Lambda, where you set it up that, okay, maybe in you can use Event Bridge scheduler to set that up. You can say, okay, maybe every 10 minutes, go and check my servers. Any server that is down, restart it. We can help you achieve that at Secure Intelligence Limited. We help you set up your Lambda function that will check the servers that you have. You can set it up to like maybe in 5 minutes. You can set it up to like maybe every 2 minutes to check your servers. And every server that is not responding, you can use AWS Lambda functions to start up that server. So we can use AWS auto scaling groups, failover procedures to switch to healthy servers, and also talked about elastic load balancers. So these services, they help you mitigate systems failure. And also logging and incident management, log application events, systems error, user interface to gain insight into potential causes of failure. So by having all this in place, by using CloudWatch, by using CloudWave, you'll be able to like have log application events, system error, user interaction to gain insight into potential causes of failure. You'll be able to see the logs. You'll be able to know what is actually attacking your services. You'll be able to say, oh, this is like a malware attack. This is where it is coming from. And by that, you'll be able to have a potential cause of failure, and you'll be able to like protect your servers, your workloads. So implementing a structured incident management process to respond to and resolve issues. When you have this process in place, when we were talking about this disaster recovery plan. So when you have this in place, you'll be able to know how to respond. You'll be able to know what to do when you have a situation, you have a disaster, you have a failure in your system. You know what to do. You know how to fix your issue. So this involves documenting incidents, identifying root causes, implementing fixes, and continuously improving your monitoring and migration strategies. So when you have this in place, when you have this documented, you know what to do. You don't just be running around. You not just be just trying anything on saving your architecture, your workload. Yeah, next slide, please. We're looking at ensuring business continuity on AWS. So this means you minimizing disruption and ensuring your critical business functions they remain operational even during outages. So the best practices on how to achieve business continuity on AWS. So when you achieve service level agreement with your service provider, I talked about durability and availability, and I said S3, which is a service in AWS, they are very durable. I talked about the 11 nines and I said, okay, they are very durable. So that is service level agreement that AWS has with its customers. So I also talked about availability. So when you have service level agreements, you 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 define metrics with service level indicators such as uptime and response time. So that way, um, uh, that way you know what to you know your target, you know the threshold you must get to. So when you have service level agreement with your customers, maybe you told you have this agreement with your customers that 90% of 90% in 24 hours my services will be down. Then you implement service level objective internally in your organization that says, oh, 95% of the time my services are going to be available. So that way you'll be able to have like a margin that says, oh, the agreement you have with your customers, you told them that you'll be having 90% availability, and what you have, the target that you have is 95% availability. But that way you'll be able to like uh, meet your business need. So you must be able to design your architecture to meet and exceed these agreed upon levels. So that was what I was saying with having service level objective and service level agreement. You must exceed these agreed upon levels. So also is business continuity plan and disaster recovery exercises. So you have to develop a comprehensive business continuity plan so that will outline recovery procedures for various disaster scenarios. So nothing will catch you by surprise. You'll be able to know what to do when you have any issue. You'll be able to know what to go to. You'll not just be running around. By having a comprehensive business continuity plan, you'll be able to know what to do. You'll be able to know where to go to. You'll be able to know what to do when a situation happens. So you should integrate this plan with your disaster recovery strategy discussed earlier. So also when you regularly conduct disaster recovery exercises to test your business continuity plan, and you must ensure that everyone on your team understands their role in a recovery situation. Everybody in your team know what to do. They all know what to do. Everybody knows what to do when a situation like this happens. So next slide, please. Also is leveraging automation to streamline recovery process and minimize downtime. So this involves using automated failover procedures, the likes of the services I talked about, elastic load balancer, auto scaling groups. You can trigger this by alert and automate deployment of new infrastructure. You can see, oh, auto scaling group can set up auto scaling group to deploy new infrastructure. So the faster your recovery process, the less disruption your business experiences. So we'll be looking at business continuity, um, benefit of business continuity. So by implementing this strategy that I talked about, you can achieve several benefits. You can have when you implement this practice, you reduce downtime and financial losses whenever you have outrages. So by doing this, you have improved customer satisfaction by maintaining service availability. When you consistently meet your service level agreement that you have with your customers, you have an increase in customer satisfaction. Also, by doing this, by following these practices, you have enhanced brand reputations and reliability. Maybe you are a financial system, and maybe it is every day that your servers are going down and your customers cannot make transactions. Obviously, it will negatively impact your brand reputation. Also, a benefit of having implementing these best practices is for you to have increased preparedness and confidence in handling disruption. So when you have this, you are prepared. So whatever happens, you know what to do, and you are confident that, oh, whatever happens, my data are safe. In quick time, you'll be able to have servers that are working. Everything is working fine. When you have a business continuity plan and you implement all these practices, you'll be able to know what to do. So next slide, please. we're looking at balancing cost and reliability. So being reliable and resilient, having reliable system and resilient, they are very crucial. But it is also important to consider the cost implication. So we are in this section, we are trying to achieve the balance between these two critical factors. So while having a robust architecture, they are important, they are essential. Over engineering for reliability can lead you to unnecessary expenses. So it is important for you to find the right balance between cost and desired reliability. So let's look at a scenario where you have critical resources that you want them to be very reliable. It actually does not make sense for you to have, like, unless maybe maybe you are FBI or maybe CIA, where you want to have your workload running in all the regions, AWS regions all over the world. Maybe you are anticipating that World War III might happen. But if that's not the case in your as a business need, there's no point in you having your servers running in all the regions, AWS regions all over the world, because of you want to have high reliability, you want to be very reliable. That is over engineering and can lead you to unnecessary expenses. So it is important for you to have the right balance and desired reliability level. So there are some techniques on how to achieve this. One is right sizing resources. When you analyze your workload, when you look at your CPU utilization, when you look at what you are actually using, what your instance is actually using, that way you'll be able to know, oh, this instance is too big for what I'm actually using. These services are actually not actually needed. These are what I need. Without you overpaying, you'll be able to meet your needs without you overpaying. So when you utilize AWS CloudWatch, like I said, helps you to monitor your resource utilization and you identify opportunities for optimization. AWS makes it possible for you to identify opportunities. It will tell you that, oh, this instance that you are using, you're actually wasting money. You can actually use something lower that will fit your business need. And by that way, you'll be able to like save costs without you overpaying. Next slide, please. Also is leveraging Spot instance. So when you leverage AWS Spot instance, this is a type of instance in AWS EC2. So AWS Spot instance makes it possible for you to like run your workload at a very significant distance. It is very cheap. It is actually different from on-demand instances. But the caveat with this Spot instance is that it can be taken away from you at any time. So when you have, maybe you are trying to experiment, you can decide to put your application on this Spot instance and try to test your how the application behaves. That way, you will be able to like save a significant distance. You might request for it is actually meant for workloads that can fluctuate. They can go off at any time. AWS can request for that Spot instance at any time. They can take it back. Actually, it is actually very the discounts on this instance, they are very low. They are not like on-demand instances. So there's no point in you using an on-demand instance when you are just trying to experiment and maybe the what you want to use it for is just maybe for 30 minutes or 1 hour. So it is better for you to like use Spot instances. Also is you leveraging managed services. We have so many managed services in AWS. We have Amazon S3, we have Amazon DynamoDB, we have Amazon RDS. So there's no point in you like having a server and installing maybe your non-SQL database on that server when there are so many managed services. Amazon DB does that work. You don't have to like when you don't have to take this route. When Amazon DynamoDB is a managed service, what this means is that you don't have to handle, you are not going to be able to, you won't handle infrastructure management and maintenance tasks. What you just have to focus on is your application logic that would talk to your database. So there are so many AWS managed services, like I said, we have the S3 bucket. S3 is a service which is a managed service. So when you need to like put in your data, when you need to store your files, you just have to like, by using your management console, you just have to like go to your S3 bucket and put in your files. You don't have any business managing the infrastructure management, or maybe you want to pass the server, you don't have that. You don't have to worry about that. AWS is going to manage those tasks for you, infrastructure management, maintenance tasks. So it just frees you for you to focus on other things. So you should consider using management, AWS managed services. So when you do this, it will free you time on focusing on other things. You don't have to like get engineers that will set up your Amazon your non-SQL database, MySQL, on a server. You don't have to do that. There are many managed services on AWS that will help you achieve that. So while managed services typically come with a higher upfront cost, they can often lead to long-time cost savings by reducing operational. You don't have to like get an engineer that will help you set that up. You don't have to get an engineer that will be patching that server. AWS does that, will do that for you. Next. So balancing cost and reliability. You have to find the ideal balance between cost and reliability, depending on your specific business needs. So, like I said, there's no point in you, unless your business warrants you having servers on all regions all over the world. There's no point in you having that. It will just it will cost you unnecessarily. It is not cost efficient. So for mission critical application, those ones you can have for mission critical application, high reliability might justify a larger upfront investment. So what this means is that for your critical mission critical application, you can adopt this concept that I talked about, high availability, having this critical application in more than one availability zone. But if you don't need it, there's no point in using it, because you have to like find the balance between cost and reliability. So for less critical workload, cost optimization might be a priority. So when you understand these techniques, you can build reliable, resilient, and systems on AWS without you wasting money. Please, next slide, please. So we'll be looking at practical knowledge for improving your system resilience. So one is security best practice. So you must implement robust security measures like access control using AWS IAM. You encrypt using AWS KMS or CMS for encryption. You perform regular vulnerability assessments for your instances. You perform regular vulnerability assessments to minimize the risk of cyber attacks. There are so many AWS services that can help you actually achieve this. We have AWS WAF that helps you like protect your workload against cyber attacks. So also is physical security. So if you are using hybrid cloud computing as a type of cloud computing where you have your physical data center and you are also making use of the public cloud, you must consider having tight physical security on your physical data centers. So by this, you improve your system resilience. When you have secure, when your in-house on-premise data center is very secure, nobody can touch it and disrupt or attack your system that way physically. So you must have this in place. You must have a very tight physical security for your on-premise infrastructure. Also is version control and infrastructure as code. When you utilize version control like Git, AWS code commits, infrastructure as code like AWS CloudFormation or Terraform. So you using all these tools, you'll be able to manage your infrastructure configuration. So this will help you to deploy faster. You'll be able to roll back in case of issues, and you'll be able to have increased consistency across the environment. I was talking about infrastructure as code the other time. I said using infrastructure as code, this is just like a template that has all the codes about your infrastructure. You can easily deploy this code into another region and have your exact business that you're having in a region, you can have it in another region. So it will help you have consistency across the environment. So next slide, please. So the key takeaway, improving your overall system resilience, we looked at leveraging AWS Well-Architected, specifically the reliability pillar for you to design the fault-tolerant system. We also looked at implementing robust backups and replication strategies for your data and application. We talked about using an AWS service called S3 can help you have robust backups. There are also like all those other strategies that can help you do this. We have AWS Snow family that you can use to have to have a robust backups where you use the Snow family to copy your data and you send to AWS. Like this is a physical equipment where it looks like a very like an handy storage device where you can use it to copy in your files and you can take it to AWS that will help you save your files. So we also looked at utilizing high availability where for configuration for critical services, where we said that we can have these services in more than a single availability zone, so that when an availability zone goes down, other availability zone will fill in the gap. So we also talked about implementing proactive monitoring and automated remediation process to help you identify and mitigate failures. We talked about using AWS services like CloudTrail, CloudWatch, and having alerts in place, and using AWS auto-scaling group for you to mitigate potential failures. So when you implement all this, it will help you mitigate potential failures. So we also talked about having service level agreements, having service level objective, and you developing comprehensive business continuity plan with regular disaster recovery exercises. So when you have this, you'll be able to know what to do when any problem occurs. And lastly, we talked about optimizing costs while maintaining desired reliability level through right sizing, utilizing spot instances, and leveraging managed services. So that is everything from my end. So thank you so much. I don't know if you have questions. I can look at them.
Well done, Moshood. That was a lovely presentation. Hope you are all enjoying yourselves as I am. If you have any questions, please put them in the question and answer section of the comment section, and Moshood will be happy to answer these questions. Also note that a calendar link has been put into the question and answer section just in case you want to consult us here at Secure Intelligence Limited. You can click on that link and it will take you to a calendar where you can book a consultation meeting with me. Okay, Moshood, are you there?
Yeah. Yes, I can.
There's a question for you. What are some common pitfalls or mistakes to avoid when building fault-tolerant systems using AWS services?
Okay, yeah, fault-tolerant systems. Okay, so when you have you don't have a single point of failure. So when you are not relying on a single instance, so that would help you. That's like when you have a single instance, that's a pitfall. Having it that way, it can go down at any time. So you have to know that you have to rely on more than a single instance. So that's number one. So number two is having adequate testing. So I talked about testing a great deal, that when you carry out regular tests, you'll be able to know, oh, these are what I can do, these are what I should do when a situation, a disaster happens. These are the processes I have to follow, so that you can easily quickly remediate the problems that you have. Also, I talked about having high availability, where you have like you have your workload, your critical mission instances or services in more than a single availability zone, so that when you lose a data center, the other data resources um, in the other availability zones, they will fill in the void. So those are ways to prevent to have a fault tolerant system. I believe I was able to answer that.
Yes, you were. Thank you very much, Moshood. I have just one question before you go. What monitoring and alerting tools within AWS do you recommend for detecting and responding to failures quickly?
Okay, I talked about AWS CloudWatch. Like, it is a essential place for you to go to, for you to be able to understand how your resources are faring. So when you use AWS CloudWatch, using AWS CloudWatch, you can set up alarms that, oh, whenever when a problem occurs, you'll be able to know. You set up alarms that will immediately tell you when the problem is happening. Or also using AWS CloudWatch, you'll be able to like see the API calls, understand how your services are interfering with each other. You have to fully understand how they are relating to each other, how they are making API calls. Obviously, services on AWS, services on the internet, they all make API calls to each other. So that way you'll be able to understand, oh, this is an attack from this quarter. You'll be able to like protect yourself adequately from them, like from them from cyber attacks gaining gaining access to your server. By using CloudTree, you'll be able to understand how your resources are faring.
Thank you very much, Moshood. This was a lovely and wonderful presentation. On the next slide, you can see you can see that you can take this to the next level with support from CIL by getting your environment well architected. And as well architected partners, we at Secure Intelligence Limited, we can help you make sure that your environment matches up to all the 6 best practices that Mushud has just spoken about. You also know that we can help you access at least $5,000 in free AWS credits when you access your well-architected environment and when you get it remediated. That sounds good, right? I know. Thank you for coming to our webinar today. Thank you for always joining us, always supporting us. On the next slide, you can see that you can see all our platforms where you can reach us, just in case you want to reach us. On Instagram, you can reach us at still_teams. On LinkedIn, you can reach us at Secure Intelligence. On Twitter or X, you can reach us at still_teams. On Facebook, we're at still teams. On YouTube, you can find a recording or any of the recordings for our well architected series on www.youtube.com/@still_teams. Do not forget that if you want to know more about how to well architect your environment and how you can go about that and doing the remediation, just click on the calendar link in the question and answer section, and it will lead you to my calendar where you can book a meeting with me and we can chat more. Have a wonderful day and thank you for joining us today. Bye.